Bismillahirrahmanirrahim. Assalamu alaikum students. Welcome to class pre-9th. Topic of this video is laws of exponents. Table of contents. Identification of base and exponents. Laws of exponents. Applications of laws of exponents. Objective number 1. Identification of base and exponent. Now let's identify base and exponent. In this expression 5 cube, the number 5 is the base and 3 is the exponent or power. The expression 5 cube is called an exponential expression. The exponent of a number tells us how many times a number is multiplied with itself. Although we don't usually write the exponent when it is 1. In general, for any quantity a raised to power 1 is a. In words, the expression in red could be called 5 to the power of 3 or simply 5 cubed. This expression could be called 8 to the power of 2 or simply 8 squared. This expression could be called 2 to the power of 4 or simply 2 to the 4th. And in general, this expression could be called a to the power of n or simply a to the nth. Example 1. Use of exponents. Here we write this expression in exponential form and evaluate. 2 into 2 into 2. Here 2 is multiplied with itself 3 times. So we write it as 2 to the power of 3 or 2 cubed, which is equal to 8. Example 2. Evaluate and write the base and the exponent. The first expression is minus 2 to the power of 6. It means minus 1 into 2 multiplied by itself 6 times, which is equal to 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32 and 32 2s are 64. So the answer is minus 64. Here base is 2 and exponent is 6. Now look at the second expression. This expression is minus 2 to the power of 6. So here minus 2 multiplied by itself 6 times. Minus 2 into minus 2 is plus 4. Plus 4 into minus 2 is minus 8. Minus 8 into minus 2 is plus 16. Plus 16 into minus 2 is minus 32. And minus 32 into minus 2 is plus 64. In this expression, base is minus 2 and the exponent is 6. Note the difference between these two examples. The absence of parentheses in the first part indicate that the exponent applies only to the base 2, not minus 2. Objective number 2, which is the main part of the video, the laws of exponent. There are 7 laws of exponents: Product Law, Quotient Law, Power of a Power Law, Power of a Product Law, Power of a Quotient Law, Zero Exponent Law, and the Negative Exponent Law. Now we will discuss them one by one. The first law, the Product Law for Exponent. When bases are same but exponent are different. By the definition of exponents, 2 to the power of 4 into 2 to the power of 3, this is equal to 2 multiplied by itself 4 times and 2 multiplied by itself 3 times. It means 2 multiplied by itself 7 times. So we write it as 2 to the power of 7. Generalizing from this example, 2 to the power of 4 into 2 to the power of 3 is equal to 2 to the power of 4 plus 3, which is equal to 2 to the power of 7. Suggests the product law for exponents. For any positive integers m and n, a to the power of m into a to the power of n is equal to a to the power of m plus n. Here, keep the same base, add the exponent. Now look at the example. 6 to the power of 2 into 6 to the power of 5. By using this law, this value become 6 to the power of 2 plus 5, which is 7. Note it. Don't multiply the bases when using the product law. Keep the same base and add the exponents only. For example, 6 to the power of 2 into 6 to the power of 5 is equal to 6 to the power of 2 plus 5 means 6 to the power of 7, not 36 to the power of 7. Is it clear? Second law, the quotient law for exponents. By the definition of exponents, x to the power of 4 divided by x to the power of 2 is equal to 4 times x in numerator and 2 times x in denominator. So we can easily cancel out 2 x's of numerator by the 2 x's of denominator. So we have left only 2 x's, which can be written as x square. Generalizing from this example, we came to know when the bases are same in the quotient, we just subtract their exponents. So x to the power of 4 minus 2 is equal to x to the power of 2. Now it suggests the quotient law for exponents for any positive integers m and n. A to the power of m divided by a to the power of n is equal to a to the power of m minus n. Bases are same, so we write the base one time and subtract the exponents only. Now here is the hint for this law. Keep the same base and subtract the exponents. For example, 6 to the power 5 divided by 6 to the power of 3. This is equal to, by using this law of quotient, 6 to the power of 5 minus 3, which is equal to 2. So answer is 6 to the power of 2. Note, don't divide the bases when using the quotient law. Keep the same base and subtract the exponents. For example, 6 to the power of 5 divided by 6 to the power of 3 is equal to 6 to 6 square, not 1 square. Now the third law, the power of a power law. We can simplify an expression such as 8 to the power of 3 whole square with the product rule for exponents. 8 to the power of 3 whole square can be written as 8 to the power of 3 into 8 to the power of 3. 8 to the power of 3 multiplied by itself 2 times. So now by using the product law, we can write the base one time 8 and add the exponents 3 plus 3, 6. It is equal to 8 to the power of 6. Is it clear? Now this example suggests power of a power law for exponents. For any positive number a with exponent m and n, a to the power of m whole to the power of n is equal to a to the power of product of these two exponents m into n. Here we raise a power to power by multiplying exponent. Now look at the example. 3 to the power of 2 whole power of 4 is equal to 3 to the power of product of these two exponents. 2 4s are 8. So answer is 3 to the power of 8. Now the fourth law is power of a product law. We use this law when bases are different but exponents are same. We can rewrite the expression for x to the power of 3 as follows. 4x to the power of 3 can be written as 4x multiplied by itself 3 times. 4x into 4x into 4x. So it is equal to 4 multiplied by itself 3 times separately And we can write x multiplied by itself 3 times separately, which is equal to 4 cubed into x cubed. This example suggests power of a product law for exponents for any positive integer m. AB whole power m is equal to a to the power of m into b to the power of m. Simply we separate the power in product. Note it. Raise a product to a power by raising each factor to the power. Now look at this example. 2p whole to the power of 5 is equal to 2 to the power of 5 into p to the power of 5. So we can separate the power in a product. Note this point. Use power rule only if there is one term inside parenthesis. Power rule does not apply to a sum. For example, 4x to the power of 2 is equal to 4 square into x square. But 4 plus x whole square not equal to 4 square plus x square. Now look at the fifth law. Power of a quotient law. Since the quotient a by b can be written as a into 1 by b, we use this fact and power of a product law to get the power of a quotient law for exponents. For any positive integer m, a by b whole power m is equal to a to the power of m divided by b to the power of m, where b is not equal to 0. Now we will apply this in an example. 5 by 3 whole square is equal to 5 square divided by 3 square. So by using this law, we just separate the power in numerator and denominator, both. Now the sixth law is zero exponent law. For this we consider the quotient law. X squared divided by x square equal to x multiplied by itself 2 times in numerator and x multiplied by itself 2 times in denominator. We can easily cancel out both these values and we have 1. This can also be written as, by using quotient law, is x raised to power 2 minus 2. Bases are same, so we subtract the exponents. 2 minus 2 is 0. So answer is x to the power of 0. From above, this value is equal to 1. Thus, we can define this law as any non-zero number x with 0 exponent is equal to 1. Means x to the power of 0 is equal to 1. Now the seventh law, negative exponent law. We can deduce this law from the product law. Consider it. A to the power of m into a to the power of n is equal to a to the power of sum of the exponent m plus n. Suppose n is equal to minus m, then we will get it a to the power of m into a to the power of minus m. Here we put minus m in place of n, which is equal to a to the power of m minus m. M minus m means 0. So in next step we can write it as a to the power of 0. A to the power of 0 is always equal to 1 by the zero exponent law. So a raised to power minus m is equal to 1 by a to the power of m. Thus we have negative exponent law. Any non-zero number raised to any negative power is equal to its reciprocal raised to the opposite positive power. Means power becomes positive when we take its reciprocal. Now consider an example. Change the following negative exponents into positive exponent. 3 by 4 to the power of minus 3. By using negative exponent law, we can write it as 1 by 3 by 4 to the power of 3. Power becomes positive by taking its reciprocal. Now by using the quotient law, we can write it as 1 by 3 cubed divided by 4 cubed, which is equal to 4 cubed divided by 3 cubed. The laws of exponents discussed in these sections are summarized in this box. Look at the laws. These rules are basics to the study of algebra and should be memorized.